So in the series of logistic regressions, this is our 7th lecture. Okay. So in this lecture, we will learn about the probabilistic interpretations of logistic regressions. So till now, we have learned about the geometric intuitions. Now we are going to the probabilistic interpretations about it. So first, so in the logistic regression chapter, till now, we have learned what? Till now, we have learned about geometry intuitions. As previously, we have announced that we learned logistic regressions as 3 ways. In first way, we learned it in geometrically, and simple something, and simple using here some simple algebra. Okay, and now we announced that we will learn in detail and briefly also, and here we will learn in detail probability using probabilistic method. Okay, and now in the end of this series of lecture, we will using loss minimization function how to okay. So it is already we have learned. Now let's go to this section, probabilistic interpretation of logistic regressions. So I will also in the description box I will also share the textbook link where you can read it in full detail and briefly also. Okay, just so first, what is the probability derivations of logistic regression? First, coming to this probabilistic derivations of our logistic regression. Okay, so here we have assumed two things. So in naive Bayes, we see that in naive Bayes, what we will see, we'll see that our features are real valued. Okay, this is the first. See. Our features all are real valued. Okay, and these features are also Gaussian distributed. This thing, our first, in what we will learn in naive Bayes. In naive Bayes, first we see that all our features are real valued features, and these functions obeys the Gaussian distribution. Okay. It's the Gaussian distribution. Number two is what? Number two, we have seen that yi, the binary classifications yi is either +1 or 0. Here we have taken. So this is a Bernoulli random variable. Okay. I think all are about know what is Bernoulli distributions. Okay, so if you not know, please go to the probability chapter, then you can find it. It is Bernoulli random variable and Bernoulli distribution. Bernoulli variable, that is our classes are. As an example, if you take an example of Bernoulli random variable, this example we can take as coin toss. So now I am just giving the, I'm just using this PDF. And if you I am giving this link of the PDF in the description box. Okay, just if you interested, then you can read this book. This is just awesome book. And so what, in this book they have just formed the probability that is P of y of x, means this is a conditional probability. Okay, this is a conditional probability and for Gaussian naive. What they have assumed? First assume they have that it is a Boolean, y is Boolean, as we previously say, y is our Boolean functions, and Boolean distribution, it is obeyed, and the parameter pi is equals to 1. E of y is equals to 1, pi is equals to, and the x is age are continuous random variable, as you see, as we discuss it. That is, our function is, our features are real valued features, and it is obeys the Gaussian distribution. Okay, it is obeys the Gaussian continuous random variable. And for age xi given, for age data point for a given, this is mean what? This is a conditional probability. Means what this is? This is means for a given class level, for each class of data points, means for each data points they have given a class level. Suppose we have a data point x1, x2, x3, suppose xn data point, and in this data point we have already given the class level. Then what will be the probability of that point is in the class level? Actually, this mean is this probability mean is what? This probability is, that is here all are denoted by capital. Means what? Means for a given class level yk, for a given class level yk, that the probability is defined that for a given class level yk, the xi point, what is the probability that xi point will be in the class level this? Okay, this is probability is Gaussian distribution from the form. This probability is a Gaussian distribution from, and of the from this means what? N of normal distribution of mu of I k for ith point k classes. So for this, for ith point, ith number of data point and k classes, we denoted the mean is equals to ik, and the variance of this is equals to I. Okay. And for all xi, conditionals are independent, and for age xi, for age our data points are conditionally independent. This thing are already we have seen it when we have read the neighbor based classifier. Then already we have seen this type of assumptions. Okay. Now, if we come to the derivation part of it, so just go read through it. Is simple. So simple paper. I think you have easily learn about it. Just go through this paper. Now, if you come to the main result, if we come to the main result, this means what? We have only here two class level. Class level is what? Here we have only two class level. I is equals to 0 or 1. Okay, 0 or 1, and we have in previously we have that our Gaussian functions. Actually, our Gaussian function is pi of x, means what? Means 1 by 1 plus e to the power x. This is our Gaussian functions, and probability of this means, probability of this means what? Probability of y is equals to 1 for a given data set. Is means this is the sigma of W transpose x. Okay, this is the sigma of W transpose x. Actually, this is, we have already seen this probability in many times in the neighbor ways, as well as when we apply the squashing technique. Then we can see this probability. This is what. But actually, this is means what? This is means 1 plus 1 to the power X means W transpose X. Okay, but here we find that here this term is actually nothing. This term is actually W transpose X. Okay, so don't be confused here, small x or capital X. Actually, we have just writing it here. Capital X. Okay. So what is W0? So W0 is nothing. Actually, we have here taking our plane as in past lecture we have assumed that our plane is passing through origin. So if our plane is not passing through origin, then what will be our equations of the plane? W transpose X plus B. But we assume that our plane is passing through origin. So here it is B here is equals to 0. So in this paper they have not taken that their plane will pass through origins. So here actually W0 is nothing, just it is equivalent to B. Okay, just similar to B here. Okay, so don't be confused about it. Just go through it. I think you will easily learn this paper. It's so simple paper. Okay. So just go through our mains. So what we have seen? In logistic regressions, we have two things. We have using Gaussian naive Bayes, okay, and Bernoulli distribution. We have using two things. In logistic regression, we have using Gaussian naive Bayes. Because of what? Because we have assumed our features are real valued and it is Gaussian distributed. And we have used our class level, our binary classifier, and because of this, it is binary, then we assume that it is a random, Bernoulli random variables. Our outcomes are this yi are Bernoulli random variable. Okay, so this is the main probabilistic approach. Okay, so this is the main probabilistic approach. Okay, so this is what, this is the probability of xi through this is xi or by yi. Okay, and these Bernoulli distributions is yi. This obeys a Bernoulli distribution. Okay, so our logistic regressions, first we assume that our data points, our features are real valued and it is obeys the Gaussian distributions, and the Bernoulli distributions is what, and our outcomes, that is yi, are the Bernoulli distribution. Okay, so all the features are real value. So first write down these equations. What we will first get it in geometrically, and first geometrically what we will get? If we geometrically what we get? W star is equals to argument of minimum W by summations of I is equals to 1 to n log of 1 plus, I think you have already know what is our geometrical equations. Is our sign distance or nothing, plus, and we have used a regularizer term. Okay, this is a geometrical equations, we have got it. And then what is the probability equations? From probability we got that our W star. So at the final day, at the end of this lecture, we have seen that these both equations are the same, nothing else. Just we are going to it. These both equations are same. I is equals to 1 to n minus yi log of pi minus 1 minus yi log of Some books use probabilistic equations, some books use geometrical equations. So don't be confused about it. Both equations are the same. Last one to regularize that term. So one thing here, yi carries two values, that is +1 or -1, but here probabilistic approach y carries two values. This is 0 or +1 or +1 0. Okay, it is the main two difference in these equations. And one thing, and here pi is what? Pi is nothing, simply probability. Probability means our Gaussian functions of w transpose xi. Okay, these equations we learned in when using the squashing technique. Geometrically we have seen that we have using the Gaussian function to find probability. So let's go to one by one. So now we just compare it, these equations, just we are find it. These equations both are nothing, just equivalent, both the same equation. Just go to one by one. First, let's consider case 1. Case 1. Okay, so first y1, let's take y1 is equals to y1, let's is positive. So geometrically what? If we consider geometrically, then y1 will be +1, and similarly if we consider probabilistically, then yi it will be also +1, because geometrically yi carries two values, +1 or -1, and probabilistically +1 or 0. So if y1 is equals to yi is equals to positive, then geometrically it will take +1 and probabilistically it will take +1. So if we apply +1 in both equations, geometrically as well as probabilistically, then what will I find? If we apply this equation, if we apply these equations in geometric part, then we got that equations will come to log of 1 plus exponential of minus w transpose x. Okay, log of, actually yi here is equals to 1. Just put the yy term, and this will go got it. Okay, so it will coming from, we are coming from it geometrically. Now let's consider the probability. If we put +1 in probabilistic equation, then what will find? So if we put y equals to +1, then this term will be 0, this term, the second term will be 0. Just rest of, we have got the rest of this term. So if we got this term, then what will go? We got -1 into yi, this is equals to 1 log of pi. So pi means what? Log of pi. This equals to minus log of pi means 1 by 1 plus exponential of minus w transpose xi. Okay, means what? Means log of 1 plus exponential of minus w transpose xi. Okay, so why we reached it? If you know already, log of minus x is equals to log of 1 by x. Just we have used this formula here, so we got it. So actually these equations both are the same, nothing else, both are the same equation. Okay, these two equations both are the same equation. So we find it that If we take yi is equals to positive, then geometrically and probabilistically both equations arise the same. Now consider the case 2 problem. Case 2. Case 2 is what? Means yi is equals to negative. Yi is negative means in geometrically y is equals to -1. In geometrically yi is equals to 0 in probabilistically. Okay, so in case 2 we got find that yi is equals to negative, and this is yi is equals to -1 in geometrically, and this 0 probabilistically. So if we put the in geometric equations yi is equals to -1, if we put y is equals to -1 is -1 in geometric equation, then what we'll get? Then we get that our equations will be geometrically log of 1 plus exponential of W transpose X. Okay, now we put yi is equals to 0 in probabilistic equation. So what is a probabilistic equation? This means yi is equals to 0 means what? This term will be 0. Y is 0 means this term will be 0, and rest of the thing is this. So just write this equation. Probabilistically -1 into log of means yi here is equals to 0. yi 0, this 0 and 0, that is -1 log of 1 minus pi. Log of 1 minus pi. 1 minus pi. Okay, so means what? Minus log of 1 minus pi means 1 by 1 plus exponential of pi means 1 by exponential of minus W transpose Xi. Just we calculated it. Simply simplify it, nothing else. Just simplify it. So in numerator we got it. Exponential of, okay, numerator we got it. So just in log of 1 by x is equals to minus log x. We have simply applied this formula here. 1 plus exponential of minus W transpose Xi. Okay, so divide numerator, simply simplify it, just nothing. This is very easily you can just divide these two terms, we get 1 and 1 plus. Don't be confused that is huge equations, huge number of calculations. Just simply just go step by step, then you can easily just arrive your target. This is this. So this is what? Log of 1 plus exp of W transpose Xi. Okay, because of 1 by e to the power minus x is equals to e to the power. Because of this, we got. So at the end of the day, we got both the equations are same. You can see both the equation, these equations and these equations are same. So both are the same equation. Okay, so in case one, we see that in positive, if our y class level is positive, then geometrical and probabilistic both equations are same. And also in case 2, we see that if our class level is negative, then geometrically as well as probabilistically, our both the equations are same. Okay, so I think you will learn how these equations, both the equations are the same. Just this is both these equations are same, just to different notations. We use the different notation to express these logistic equations. So don't be confused about it. Some books use geometrical equations, some books use probabilistic equations. But in this lecture, we have used here geometrical equations because we designed this course through based on geometrical. Because geometrical are visualized, and I think it will very suitable to understand. Okay, and if you want to read the details about briefly about the probabilistic interpretations, then I recommend you just go through this paper. I think just go through this book. I think it will be very simply explained. It is in this book, it is simply explained, and step by step they will explain how they will arise in the logistic equations from the probabilistic using probabilistic approach. Okay, I am giving this link. I am just giving this link in the description box. Just go through this link.